everyone, welcome back to the Loughborough University's Women's Engineering Society STEM Club. There will be a video going up weekly that will hopefully inspire you and teach you about different STEM-related topics. A quick recap, STEM stands for Science, Technology, Engineering, and Mathematics. My name is Vanna, and I'm a second-year Product Design Engineering student, and I am the media rep for the Women's Engineering Society. And today I'm joined by
Anna. I'm a second year student who studies civil engineering.
And Rhiannon, I'm a second year student and I study robotics, mechatronics and control engineering.
All right, before we get to the experiment for today's episode, we will talk a little bit about our courses. Would anyone like to start about letting us know a little bit about their course?
I can start. Robotics at the moment, we've covered quite a variety of different topics. So we look at electronics, so circuits and electricity, mechanics. So we look at forces and structures. There's also quite a bit of maths involved as well. And we put it all together and we look at how we can use it in like robotic structures. So if we had like a little robot arm, how it's going to go and pick stuff up.
That's really interesting. Hannah?
Yeah, so I do civil engineering and we do anything from rivers, understanding how water flows through the landscape, from geology to what's under the ground. Then we also do structures, including like buildings of how they combat, like how they interact with the winds, with different loads, and yeah.
Thank you for sharing that. I'm a product design engineer, and we're responsible for the process of creating and developing new products or improving the performance of existing ones. I think that product design engineering lets you be part of the invention process. So everything around you, things you use in day-to-day life, has been designed by an engineer and then manufactured by an engineer, and I get to be part of both those processes, which I think is really cool. Today's experiment is the spaghetti marshmallow earthquake tower. And so you're gonna need a couple things to start off. We have our spaghetti. All three of us have spaghetti with us. And then we have our marshmallows. I believe that all of us have different sized marshmallows, which is fine. Just use whichever.
Got mini ones and regular size ones.
I have these medium sized ones. I think these might be regular sized actually.
Yeah, it's about the same.
Yeah. And this is a very simple experiment. It's really, really cool because you'll be building a tower that has to carry a small load. I have a ping pong ball that I'm hoping my tower will be able to carry. And we're gonna learn about a little bit about structures and how different structures are affected. We'll also talk about earthquakes in a second and what they are and how it relates to this experiment. Using your spaghetti, you can, we're gonna start building the towers. For our first try, each one of us will be putting a different shaped tower together. Everyone will be doing their best, but the steps are fairly simple. All you have to do is get one spaghetti. You can either keep it the size it is, or you can break it down if you feel like breaking it down will be more helpful for building the structure. It's really easy to snap. And then you'll be using your marshmallows as little, I think we can call them joints. They'll act as like the glue between your spaghetti. And then you can just go ahead and make any structure you would like. Each of us will be making a different one. We don't have a set structure in mind. It's just seeing how we can make it as strong as possible. We'll be showing you as we go. I am starting off by making a nice square base.
I've done it with making 4 individual columns and then seeing how that goes.
Just going with it. This is my base, and we'll build off of this.
I've also made a square, but it's not my base, it's just a square.
Right, as we're going, I wanted to ask you guys a little bit more about your course and how you guys are finding university, what you guys think about it. Hannah, if you wouldn't mind starting off by just telling us what you like about your course.
Yeah, so I like that the course is so varied and it like links with so many other things. So it uses your maths, but then it also uses like knowledge of like geography and the physics behind everything, and also that you can see it like in the world around me. So as I'm going for walks and stuff, I can spot out things that I've learned in lectures, etc. So it links all together.
Yeah, I think I didn't realize how much engineering plays a role. I don't think you think about it until you're actually.
No, exactly. And it's all the different like disciplines which are involved within the like maintenance and the design of everything. So
Yeah, that's cool. Rhiannon, go for it.
I quite enjoy my course. It's quite a fun course because there's so many things that I've learned before, like at college and at secondary school, all the different like maths and physics sort of things, programming. There's a lot of different things in it, and you see how you can fit them all together to do something even better with them than you did before. And you get to mess with robots and program them, which is always really cool. Yeah, and you get to see how things work. So, you've got like production lines and you've got all these robots that assemble things like a car. You get to see how it knows where the thing is to pick it up and not to squish it when it picks it up, which is really cool.
Yeah, I think robotics, when you hear that, you automatically, it sounds really, really interesting and really cool. And just being able to like work with that must be quite fun.
yeah, have you had to be able to like use robotics much in like your course and like your labs?
Yeah, I have some robots with me at the moment actually for our project that we've got going on at the moment. And it's called the Robot Olympiad. So different groups get different robots and we program to do different events. Mine's a gymnastic event, so we're gonna get out. We've got 2 robots, and they're gonna like do a little dance routine together to some music with some flashing lights. They're gonna try and get the one to pick the other robot up as well.
So that sounds amazing. That sounds like so much fun.
Yeah.
I do product design engineering, which is a mix of design and engineering, which I thought was really cool because when it was time to start applying to go to university, I was kind of torn between design and engineering. I really like math and I like physics, and I also like design. And so that product design engineering kind of just offered a middle ground between those two things, which I thought probably was what I was looking for in a major. And yeah, so I really like the mix. We get to work on both sides, and then we also get to mix them together.
Sounds good that it's like quite varied. Like in your like each module's not the same and it'll overlap and stuff.
Yeah, you get a chance to kind of experience different parts of I want to say engineering, because even the design is very engineering based, which is
I
also
think engineering is so broad, isn't it?
yeah.
It's more
And
people.
at university, they've been giving us the opportunity to kind of work on very like a whole bunch of topics. So it's not, you don't necessarily go out into just one field, you can choose which field you're going into, which I think is amazing.
Yeah.
To be able to choose. I've made this little cross to kind of make my base more concrete. I don't know how well this is gonna work out, but we will see at the end.
Definitely fiddly, isn't it? But...
Yeah, it's a little difficult because spaghetti keeps snapping.
Yeah, I've got very low quality spaghetti here as well. So. I'll make sure you keep all the same lengths as well.
Yeah.
Oops.
This is what mine looks like so far.
I'll try and get this bit to be stable. Do some cross bracing, shall we?
Hannah, you said you work with so you guys look at structures and how they're affected by external factors. Is there anything specific that you learned that kind of surprised you, or was it all just very expected?
I think you don't realize how much there is behind the like considerations that you make before you would have to even just like the building the structure. So normally you have to have so much more understanding of the ground below it, which you obviously wouldn't really think about, but obviously that's like the vital part because that's the foundation of your actual building. So I think it's quite interesting to realize that, and you have to have a proper in-depth understanding of the ground to then what sort of foundations you use or like what material you can use on the structure, because obviously it's not gonna stay up very very long otherwise. So yeah.
Right, that makes sense. I would not have thought of that. I don't think you consider the fact that your base is where you should start.
It's kind of like this, isn't it? You have to think about that. But yeah, and often when you're on a building site, often like the public will look at the building and don't see the initial build, obviously the actual structure being built up. So they think, oh, no work's been done, but actually the most vital part, you could technically say, of understanding the ground below it and stuff is being done. So
yeah. I think I kind of realized that in product design engineering as well, just because you don't notice that everything around you had to be thought about and designed by someone, and they had to think about how it would look like and how it would function, and just little things where if you aren't looking for it, you wouldn't really pick it up. Then you start picking it up and you realize someone put a lot of effort into making things like the coffee machine that your mom uses, or little things. I have made these for skewer-like things and used two spaghettis. Two spaghettis for extra reinforcement. I'm trying to figure out what my strategy is for this. I think make it as strong as possible is the strategy. So
working as we go and just adding bits when it's about to fall.
Making it more concrete.
I would lift mine up to show you, but I don't think I can.
I did want to ask you guys what your favorite projects have been on your courses so far.
I think my favorite one is we have a cross-week program within my school, where you have within the construction industry, which is I guess what you would call my course falls under. We worked with different disciplines. So we had architects who do all the design of it. Then you also had the QSs who they do all about the money and how it's going to all work. And then you have the civil engineer, who considers the stability of it and the lifespan, how long it's going to stay up for, stuff like that. And we all had to work together using all our different different skills to try and produce a structure basically, and how it would have all fit together and that sort of thing. It's really good, interesting to meet other people who do similar courses to you, but not the same. So you get to learn about what they're learning about and how all your parts fit together, which is interesting.
What's the difference between a civil engineer and an architect?
So an architect is more about the function of the building, you could say. So they consider more about how the space is going to be used and like how it's going to integrate, like how it's going to look within the environment and that sort of thing. But then the civil is more, is it going to stand up? Will it last however many years that the structure needs to last for? So yeah,
A lot more practical elements of it.
yeah, let more numbers, you could say, than the architects. Yeah. all is needed for, because I feel like they say if a civil engineer built a building, it wouldn't look very pretty. No one would use it. So
Yeah.
we all need our parts. Some of us are more creative than others and can use spaces more than others. So
Very true. Yeah, we work with manufacturing engineers quite a bit, and you can tell that we're the people who really care about what things look like, the colors and the shape. They will spend most of their time making sure it functions properly and that the structure is proper and that everything is done correctly according to the mathematics behind it. But then we're there looking at the aesthetics as well, making sure that people, the public want to use
people actually use it.
Mm-hmm.
So yeah, that makes sense. Standing up, that is a positive.
Rhiannon, have you had a favorite project since?
I think the favourite one is the one that I mentioned earlier, the Robot Olympiad, because my last year's project was really exciting too. We built our robot and we had it we got a brief from a company and they wanted like an autonomous robot. So what we did was we made a line following robot, so it would follow a path drawn out on the floor. So if it was like going around campus, for example, it could follow the path going around to where it had to be and do different things. And you get to see a lot of the different considerations in it. So like you look at like the safety aspect, because if it's autonomous, there's no one driving it. What if someone walks in front of it? So you need different sensors to say there's something in front of you, you've got to stop. But this year, that's a lot more creative with it. So with our project, we can do anything we want. So anything we've ever learned about, we can apply it to this. And there's a lot of programming in it as well, working on the lights and making it look cool.
That is, we as product design engineers, we had one project where it was called mechatronics, and we had to build a small buggy that followed a line, and that was very difficult. So I'm really impressed by the fact that you guys are working towards that. We really struggle.
Yeah, there are lots of different ways you can do it, and that applies across all of engineering, isn't it? Like with this, there's not one exact solution for it. So there are different pieces of technology you can use and you still get the same result in the end, that it follows the line. It just depends on what exactly you want it to do. So we looked at different ways we could have implemented it in the end, but we just used two sensors that sensed where the line was. So if it went off the line, it could correct itself and come back on it again.
Yeah, that's really interesting.
That sounds so cool. Yeah, you hear about these things and you see them in films and you're like, how is it actually done? And then I'm seeing someone who actually does these things and you're like, oh wow. Yeah, like this. It's very bulky and it's not very
This is what I have at the moment.
That looks good. That looks really good.
Cool. Yeah, It's hard with measuring the spaghetti because as you snap it, they all go different lengths, and obviously I'm
Yeah.
not really measurements of any sort. I don't know whether to go to the next level or not, or build it up and then squish it on.
Yeah, I know what you mean, because I think mine's gonna start looking wonky just because my spaghetti.
Yeah, it's kind of, if I look, it's very, yeah, not regular member lengths, but never mind.
What are you thinking of doing?
I think I might go up, just go above. Let's just go for it. Why not?
I think since we've reached a point where we kind of have structures now that we're building on, we should probably talk about what an earthquake is. So the surface of the earth, called the crust, is not made up of one solid piece. It's like a jigsaw puzzle. There are approximately about 20 pieces, and each of these puzzle pieces are called a plate. And these plates are constantly moving. Fortunately for us, they don't move very fast. When they move, they scrape over each other and they bump, they drag along, and so it makes these earthquakes. Usually they're too small for us to feel, but when they're bigger, that's when there's a problem. That is what we're going to try to do today. We're going to build these structures, then we're going to shake the table a little, making an at-home earthquake to see if our structures can withstand it and if it can keep carrying the ping pong ball.
So what did you guys do before you came to university? Like, what did you study?
So obviously I did all my GCSEs. I enjoyed science and maths, and I did STEM club at home. And then in sixth form, I took maths, geography, and physics. And during that, I also helped out because obviously I enjoyed STEM club at a lower when I was younger. So I decided to also help out at my school there because my sixth form joined on to the school I went to. So then I was able to join in STEM club and help there, and then help also in science classes and that sort of thing. So yeah.
Really cool. What A levels did you guys do?
I did maths, further maths, physics, and computer science.
Right.
So I knew I wanted to do something engineering when I chose them. And I know maths definitely keeps your options open. Like no matter what you're thinking of doing, maths is definitely a great subject to go for.
It's hard.
And I really enjoyed it. It's hard, yeah.
It's hard, but you get there. Just have to persevere with it, and you'll get there.
Exactly. So I did further maths as well because I really did enjoy maths. And I didn't regret it either because a lot of the maths I did in further maths I was doing again when I came here and still am doing now. And all of the subjects that I picked fit really nicely into sort of the electrical, electronic, robotics, computery sort of subjects that we have here. So a lot of the skills that I learned there transferred straight over to my degree, which I thought was really exciting as well. Because normally when you learn stuff, especially in maths, you don't know how it's applied. You just think you're learning it for the sake of learning it. But a lot of the stuff we've learned, you can see how it's applied to in the real world.
I think that's
It's definitely true, yeah.
Yeah. You don't realize how much of it is, applied and how important it is that we know this stuff.
Yeah, I think that with Michael's because there's always every time you're in like year 9 or whatever maths, and you're like, how is this going to be useful? And then later on, you're like, oh.
And trigonometry with the shape of the structures we have here.
Yep.
Lots of triangles.
Absolutely. I don't know if these count as regular shapes because it's very
irregular, isn't it?
Very irregular.
Well, very irregular, but already staying up. But we'll get there.
I went to an American school, so I didn't do A levels. I had a whole different system of testing and being graded and stuff. So it's always really interesting to hear about your guys' experience with it, especially because I know that product design is given as an A level, and I didn't get to do that. Well, many of my friends did, and so you can see that they really like it, and that's why they decided to go for product design, which I think is really interesting. Right. I think what we're gonna do is we're probably gonna go and complete building our structures, and we'll come back with our completed structures in a little bit. Yeah. Okay, we're back and we have finished our structures. Each one of us has come up with a different structure. Unfortunately, Hannah's been told up. Hannah,
It's not stayed up, no. I think the spaghetti length side cut were not all the same, therefore, yeah, the weight of them all collapsed in on itself and it can't stand up. So this is what we have.
but that's okay. It's important that you think about the design process as you're going through building the tower, and as long as you think about it and you learn from it, that's the most important thing. You don't need to have a 5-meter tall tower. It's just
It's what you learn.
It's what you learn. It's trying the experiment.
So you do the same thing next time.
We're gonna test them out now. We've made little nests at the top using just little spaghetti pieces. You can just break off the spaghetti and stick them in the marshmallow at the top to make a little nest so it can hold the ping pong ball. And first we'll make sure that the structure can actually hold it, which it seems that both of our structures can. And now we're just gonna shake the table a little to imitate an earthquake and see if our structures still hold up. Okay, on 3. 1, 2, 3. I think both of ours pass. We should probably talk about what we think are the strong points and then the weak points of our structures. Who would like to go first?
I'll go first. I think my strongest point of mine was the base. It's quite wide, so it goes up, makes a big point, and there's lots of triangle shapes in it. They're pretty strong. So because it had a nice strong base, it didn't wobble at all, and so it held the ball up really nicely.
I agree. I think yours looks very, very solid. Even just looking at it, it looks clean and like very. I would
very
trust.
regular, isn't it? Like,
Yeah.
it's very symmetrical.
Mm-hmm. I would trust your structure to
Mhm.
hold my ping pong ball. Hannah, tell us about your structure.
I think, as we've said, the pieces are all different lengths. Like the sides of them are all different lengths, which obviously doesn't help. So then the weight of the marshmallow is slightly over, like where it should be supported with spaghetti. So I think that's caused it to not be able to support the weight of the marshmallows, and obviously not even a ping pong ball. So that's probably the issue there.
Yeah. The thing that was probably the most helpful is that I didn't break off the spaghetti for these sides. I just used full spaghetti and I slid a marshmallow in through it, so that way the joint just is a little bit stronger because it's not floating inside the marshmallow. It goes all the way through, which I think probably helped a lot. I also did try to have some sort of structure, so like here, to support and reinforce, which I think helped. But overall, I think we did a really good job. It was really fun trying this out with you guys. I hope everybody watching will get a chance to build a solid structure as well, and that you've enjoyed this. Don't forget to check out the worksheet that's linked with this video that will walk you through some of the things we did today. Yeah, it was really nice speaking to you guys. And just stay tuned till the next episode.